Alright folks, welcome back. I've got another problem lined up for you guys. Question 17 from the first chapter of the Johnston textbook, and let's break it down step by step. In this one, when the force P reached 600 pounds, the wooden specimen shown failed in shear along the surface as indicated by the dashed line. We need to determine average shearing stress along the surface at the time of failure. So what's going to happen in here is that we have the force P that is applying on the right side of this wooden specimen, and it's gonna experience a shearing stress in the dashed line, which is what we have in here. So it will be the shaded area that we have that's gonna experience the shearing stress along that surface, and we know that would be F, or our force, divided by the area of that shaded area, which we know one side of it is 3 inches and it's also 0.6 inches thick, as we can see in the figure. So easy enough to find the area, and we know when the force P reaches 1600, that's our cutoff for failing the wooden specimen. So we have the force F applying in the opposite direction of P, and here, since we are in equilibrium, basically we have a 2D question. If we look at it in the main figure, and we have the force F on the left side and P on the right side, we can consider our X and Y in this direction. So if we do sum of all forces in X direction is equal to 0, this is our positive X, we basically have P minus F is equal to 0, and we know once we reach that 1600, that's where it starts failing. So when our P is equal to 1600, that would be our maximum force for F. So now that we have the force F in here, we have the area 2. We know we have to find the area of the shaded part in this figure, which is pretty easy. We have a rectangle, one side is 3 inch, the other one is 0.6. So we can find the shearing stress very easy. The force is 1600 pounds, and we have the area 3 times 0.6 inches squared, and if we calculate this, we're gonna get 888.9. Since we have pound and inches squared here, we're gonna get PSI, which would be the final answer for this question. So yeah, that's it for today. Let me know if you guys have any questions regarding this one or the other textbooks that we're covering in the channel. Feel free to check out the playlist. We also have another channel where I specifically solve engineering mechanics questions. I'm gonna put the link in the description below if you guys interested in that course. Feel free to check it out, and please make sure to subscribe to the channel, like and comment. It's gonna help me to reach out to more students, and you guys take care. I'll see you in the next video. Have a good one.